We're going to review some of the trig that you might have learned in the past, just to do a recap before moving forward. So let's start with the Pythagorean theorem. So we have a right triangle. We have sides A, B, and C. So A and B are legs. C is hypotenuse. And the formula is a squared plus b squared equals c squared. So let's take an example. Let's say a equals 4, b equals 5, and c, we don't know what c is. So we plug it in here. We have a is 4, so we have 4 squared plus 5 squared equals c squared. This becomes 16 plus 25 equals c squared. 41 equals c squared. Square root of 41 equals c. Alright, special right triangles. So we have two special right triangles. We have the 45, 45, 90. X, X, and X root 2. And then we have the 30, 60, 90. 30, 60, then our right angle 90. And we have X, hypotenuse is 2X, X root 3. So if I give you one side and two of the angles, which is usually going to be one of the 90-degree angles, then you should be able to solve for the other two sides. So let's take an example, right? Let's do, I gave you 45 degrees, and I said this is 3, and I want you to find the other two sides. So since over here we have x, x, and x root 2, so these two legs are always going to be the same. So we know that this is 3, and then to get to the hypotenuse, we have to multiply by root 2. So it's going to be 3 times root 2. All right, let's do the reverse. Let's do 5, right? So in order to get from the hypotenuse to the leg, we have to divide by root 2. So our answer is going to be 5 divided by root 2. But we actually don't want a radical on the bottom. We're going to want to simplify that. So we'll come back to that. Right? But remember, so to go from leg to hypotenuse, we multiply by root 2. To go to hypotenuse to leg, we divide by root 2. And you can say the same thing for 30, 60, 90 triangles. Right? So we have our 30. If we have 4, we're trying to find the other two sides. Well, we know that the hypotenuse is 2 times that, so it's going to be 8. And then the longer leg is going to be x times root 3. So 4 is our x, so it's going to be 4 times root 3. All right, trig ratios. This is SOHCAHTOA. So we have sine of theta, cosine of theta, tangent of theta. And then the reciprocals, we have cosecant of theta, secant of theta, and cotangent of theta. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cosecant, and then these three are all just flipped. So h over a and a over o. Right? So that's how we get, right? So sine, cosine, and tangent. SOHCAHTOA. So if I were to give you a right triangle, I'm saying this is my theta, and I have x, y, and z. Sine of theta would be the opposite, so y over the hypotenuse z, right? So I'm going to rewrite this triangle. This is our theta, this is our opposite. This is our hypotenuse. This is our adjacent. Right? SOHCAHTOA. Alternatively, right, if I had another triangle, and this was our theta up here, then our new opposite would be over here. Hypotenuse adjacent, right? Because this is now opposite of our theta. So depending where the theta is, your opposite will change. But the hypotenuse is always diagonal of the right angle. All right, and then finally simplifying radicals. So let's take the example from up here, right? We have 5 over root 2. So we never want a radical on the bottom, so we're going to multiply by 1. Because we can't change the value. If we multiply by anything other than 1, we're going to change the value. So this becomes 5 root 2 over root 2 times root 2. So 5 root 2 over root 4, which is the same as 5 root 2 over 2. We could also do, let's look at 4 divided by root 8. So again, we want to multiply by 1. We get 4 root 8 over 8, but then we have to simplify this. So see this 4 over 8, we have to simplify it. So we get 1 root 8 over 2. So this becomes, instead of 4 halves, we're going to have 1 half. Like 4 over 8 becomes 1 over 2. So we can just write that as 8 over root 2. Actually, you could go even further and simplify this. So we have root 8 over 2. That's the same thing as root 2 times root 4 over 2. And this becomes 2. So it's 2 root 2 over 2, which is the same thing as these cancel out, just root 2. So you always want to see if you can pull out fractions from, if you can pull out roots from radicals. But you also never want to have radicals on the bottom. Alright, we're used to find the missing side of a right triangle. Sides A and B are called legs. Side C is called the hypotenuse. For any right triangle, a squared plus b squared equals c squared. And you can see right here they have the picture, a squared plus b squared equals c squared. So now let's go through the examples. They want you to round it to the nearest tenth, but I can say keep it in radical form. So we have a, b, c. So we have a squared plus b squared equals c squared. 8 squared plus 13 squared equals c squared. 8 squared is 64 plus 169 equals c squared. What is 64 plus 169? So we have 64 plus 169, 233. So then we just have c equals the square root of 233. And I don't think that can be divided by anything. All right, 2. A, B, C. So these two you're solving for the hypotenuse. Now we're going to solve for a leg. So we have A, B, C. It doesn't matter which leg you chose for A or B, right? The only thing that matters is that C is the hypotenuse. So it could be A and B, or this could be B and A. Doesn't really matter. So now we're going to subtract 49 from both sides because we want to solve for B. But we can write this as something else. Alright, now we're in decimals, so let's just give the answer with decimals. Then we subtract the 364.81 from both sides because we're trying to solve for x. And then we have to take the square root of that. So I'm going to do square root of the previous answer. That gives me round to the nearest tenth. Alright, now it's getting a little trickier. So we have A, B, and C. So we know A. So the whole thing is 22, but we're only looking for A. So since this is an isosceles triangle, we know that this perpendicular cuts it in half, so A is actually 11. And then B, we still don't know. And then C is 24. Then we subtract 121 from both sides. So we get B equals the square root of 455. I don't think you can simplify that further. Alright, so now we get this weird shape, but we want to recognize, okay, we like triangles. So we're going to drop the perpendicular. This is still x, and then this is our new side. So we have A, B, and C. So we know we want A. The whole thing is 18. We know that this section right here is 5, which means that this section right here is going to be 18 minus 5, which is going to be 13. B, we still don't know. And then C is 16. 69 plus B squared equals... Subtract 169 from both sides because we're trying to solve for B. I guess for here I should write these as x equals. So x squared equals 87. So x equals the square root of 87. Alright, 7. So we're trying to figure out x. So we actually have two triangles. So A and B. And then over here we know that A plus B equals x. So we have A. So let's do this triangle first, right? This is A. Maybe let's call this A1 and A2. We'll call this B. So A1 squared plus B squared equals C squared. So A1 squared plus 12 squared equals 14 squared. I keep putting an equal sign, but it's plus. Minus 144 from each side. A1 squared equals 52. So A1 equals square root 52. And then we have A2 squared plus B squared equals C squared. So A2 squared plus 144 equals 29 squared. Minus 144 from both sides. Take the square root of that. And then we just want to add them together back to get to x. So square root of 697 plus square root of 52 equals 33.6. Alright, so let's do, this is B, this is A. So let's start with this triangle to find B, and then we're going to find A. So we have 10 squared plus B squared equals 25 squared. It's 25 squared, I should know this. 625. So B squared equals 525. So B equals square root of 525. So then we have B squared. So A squared plus B squared equals C squared. So we have X squared plus B squared, which we know is 525, equals 28 squared. Well, we can write this as a square root squared, which just comes back to regular. So we have X squared plus 525 equals 784. Subtract 525 from both sides. So X equals square root of 259. Alright, here we know that this whole base is 40, and we know that this is 26. So we know that this plus this is equal to 40 minus 26, which is equal to 14. And then we know that these two are equal, so we know that they're both 7. So this is 7, this is X, and then this is 20. So we have A squared plus B squared equals C squared, X squared plus 7 squared equals 20 squared, X squared plus 49 equals 400, X squared equals 351, X equals square root of 351. Draw a picture, then solve for the missing side. This is our house. This is our ladder. 16. The base of the ladder is right here. It's 5 feet from the house. How high up? So we have question mark squared plus 5 squared equals 16 squared. 16 squared minus 5 squared equals 231. And it's feet. It's building a desk. 10 by 23, and he wants to know the diagonal. So we have 10 squared plus 23 squared equals diagonal squared. We have, so diagonal equals square root of 629 feet. You can put this in decimals, but I'm just putting it like this. Ashley jogged 3.4 miles east and then 5.7 miles south. How far is she from her starting point? Then we take the square root of the answer. 6.6 miles. It's a long run. Alright. 31-foot support wire is attached from the top of a 25-foot telephone pole to a point on the ground. This is 25. This is 31. How far is the base? So square root of 336. Alright, special right triangles. So we have our leg is x, our hypotenuse is x times root 2. So we know that our legs are always equal, so we know that x is 8. And then we know that this is going to be, the leg to the hypotenuse is times root 2, so it's going to be 8 times root 2. So here, again, we know that in a 45, 45, 90 triangle, the legs are the same. So this is going to be 25. And then we're going to multiply by root 2. This one's a little trickier. So we know the hypotenuse, and to get to the leg, we have to divide by root 2. So 19 divided by root 2. But then we want to get rid of the radical on the bottom. So we times it by 1, or root 2 over root 2. We get 19 root 2 over 2. And since both of the legs are the same in a 45, 45, 90 triangle, this is the answer for both of them. So for 30, 60, 90 triangles, we have our shorter leg is x, the longer leg was x times root 3, and then our hypotenuse is 2 times x. So we have our shorter leg. We know the hypotenuse is 2 times that. And then our longer leg is the shorter leg times root 3. Alright, so for this one, we have our shorter leg is right here, right? Shorter leg is always across from the 30-degree angle. So our hypotenuse is double that, 2 times 14, and then our longer leg is 14 times root 3. Here, we have the hypotenuse. We know that the shorter leg is half of that, so 32 divided by 2. Which equals 16, and then the longer leg is going to be the shorter leg times root 3. Again, we have the hypotenuse. The shorter leg is going to be 46 divided by 2. And the longer leg is going to be the shorter leg times root 3. Here we have the longer leg. So to get from the longer leg to the shorter leg, instead of multiplying by root 3, we divide by root 3. So we get 20 over root 3. And then to get from the shorter leg to the hypotenuse, we double it. So it's going to be 40 over root 3. But we want to simplify. We want to get the radical out of the bottom. So our y is actually going to be 20 root 3 over 3. And then our hypotenuse is going to be 40 root 3 over 3. And for here, we have our longer leg, which is 9 root 3. So to get from the shorter leg, we just divide by root 3. This becomes 9. And then to get to the hypotenuse, we double it. It's 2 times the smallest leg. So for this one, we go from the hypotenuse to the leg, so we have to divide by root 2, because we're in a 45, 45, 90 triangle. So now we're mixing. Now we're doing all different types. It's going to be 28 divided by root 2. But remember, we don't want a root on the bottom. So we get 28 root 2 over 2. With that simplifies to 14 root 2. And they're the same, because both the legs on a 45, 45, 90 triangle are the same. Here's the hypotenuse. We need the shorter leg, which is 8 root 3. Here we know x is the same, 4 root 2. Here we know that the hypotenuse is doubled, and then the longer leg is just times root 3. Here we know to get to the shorter leg we have to divide by root 3. So we know that this is 15, and then we can go to the hypotenuse, which is just double that. Here we have the hypotenuse, but to get to a leg, we have to divide by root 2. So we get 9, and they're both the same, because it's 45, 45. Here we have, to get to the shorter leg, we need to divide by root 3. So 6 divided by root 3. We want to reduce that, simplify it. So 6 root 3 over 3, but that turns into just 2 root 3. And then to get from the shorter leg to the longer leg, to the hypotenuse, we double it. So 4 root 3. Here we're at root 10. We're trying to get from the hypotenuse to the shorter leg. So we go root 10 divided by root 2, which is the same thing as root 5. You could also think of root 10 over root 2 times root 2 over root 2. So root 20 over 2. Or root 20 you can rewrite as root 4 times root 5, which is the same thing as 2 times root 5. And then that reduces. So it's just root 5. And then here, we know the shorter leg is half of the hypotenuse. So this is going to be 19, and then this is going to be 19 root 3. Alright, now we have some combinations. So we're going to have to do one triangle first, and then the other. So look, we have this 9 here, which means that this is 18. This is 9 root 3. And then to get from the hypotenuse to the leg of a 45, we do 9 root 3 divided by root 2. But then we want to get rid of the root 2, so we get 9 root 6 over 2. Here, we know that this is 32. This is 32 root 2. So we did this first, the 45, 90 triangle, and now we're going to go to this 30, 60, 90 triangle. So this is half of the hypotenuse, and this is just that times root 3. Here, let's start with this 30, 60, 90 triangle, and then go to the 45, 45, 90 triangle. So we know that this is hypotenuse is 12, so the shorter leg is going to be 6. This longer leg is going to be 6 root 3. That means this is going to be 6 root 3. And then to get to z, we have to do 6 root 3 times root 2, which is the same thing as 6 root 6. So 6 root 3, 6 root 6. Okay, let's start with this triangle, and then we'll start with this triangle. So this is 60, which means that this is 30. So the hypotenuse is going to be double our shorter leg, so it's going to be 14 root 3. And then to get from the shorter leg to the longer leg, we have to multiply it by root 3. So that's just the same thing as 7 times 3, which is 21. So this is 21, which makes this double, 42, and this makes this 21 root 3. So x is 14 root 3, y is 42. Last two. So let's start, right, we have a value here, so let's start with this triangle. So that means that these two legs are going to be 15, because we have to divide by root 2. So if the longer leg's root is 15, 15 divided by root 3, so we need to simplify. So this is 5 root 3, which means this is 10 root 3. This is 15. Alright, let's start with a 30, 60, 90 triangle, and then we'll jump to the 45, 45. So we know that the longer leg is 18, so we need to get to the shorter leg, so we divide by root 3. Then we have to simplify. This is 6 root 3. That means this is 12 root 3. Then we have to get the other ones, 12 root 3 divided by root 2. So root 2 over root 2. So 12 root 6 over 2 is equal to 6 root 6. Okay, this is just more practice, so I'm going to post the answers. Alright, trig ratios. What is trigonometry? I actually don't know what we're going to fill that out. So sine of A, right, if this is angle A, then the sine is going to be the opposite, A over hypotenuse. Sine of B, so if we're over here, then the opposite is now B. The hypotenuse is the same. I'm just going to write here. So, TOA. So cosine, if we're over here, cosine, the adjacent is B. And then if we're here, then the adjacent changes to A. Remember, the hypotenuse is always the same. Hypotenuse is always C. Tangent, if we're at A, then opposite is A over B. But if we're over here, then it's B over A. Right? So this should be a quick review, not too bad. So So A, sine of A, so right, if we're right here, you have opposite over hypotenuse. Cosine would be adjacent over hypotenuse. And tangent would be opposite, which is 5, over adjacent, which is 12. Right? So if I'm sitting here at A, my opposite is 5. But if I'm sitting here at C, then my new opposite is 12. Right? So we have 12, but the hypotenuse is the same. My new adjacent is 5. And then my new opposite over adjacent is 12 over 5. Right, this one now we have to do the Pythagorean. So do 9 squared plus 12 squared equals C squared. 9 squared plus 12 squared, 225. So this is 15. So if we're standing here at W, my opposite is 12 over 15. Let's reduce that to 4 over 5. Adjacent is 9 over 15, which is 3 over 5. And then our opposite over adjacent is going to be 4 over 3. Right? And if we're here at X, right, then our opposite is now 9 over 15, 12 over 15, 9 over 12. So 3 over 5, 4 over 5, 3 over 4. Alright, let's find the missing side using Pythagorean. So, question mark squared plus 16 squared equals 34 squared. 34 squared minus 16 squared equals 900. So that's 30, pretty sure. Yep. So over here at L, our opposite is 30. Hypotenuse is 34. 16 over 34. 30 over 16, 16 over 34, 30 over 34, 16 over 30. So this becomes 15 over 17, 8 over 17, 15 over 8, 8 over 17, 15 over 17, 8 over 15. So just knowing where you are in the triangle and knowing what is opposite. Alright, simplifying radicals. So we have a fraction over a fraction. So since this is the same thing, this is just 1. Right? So we have root 3 over 2 times, or over 1/2. So let's multiply by 2 over 2. So this becomes root 3 over negative 1, which is just negative root 3. Alright, so since they have the same denominator, we can simplify these. Let's take a look at this one. So we have root 3 over 2 divided by negative root 2 over 2. So we just do times 2 over 2 to get rid of it, the denominator. So we have root 3 over negative root 2. And then we need, sorry, there's not that much room on this paper. So we need to multiply by root 2. So we get root 6 over 2 negative. Let's take a look at 57. Times 2 over 2, we get 2 over root 3. So we need to times that. So we get 2 root 3 over 3. Great, so just a lot of practice. Oh, and here's a typo. Shouldn't be an S there. But 1 over 1's not that bad, right?